All right, so one of the most, and I could say this about a lot of things in math, but one of the most important things we're going to have to be able to do to be successful in this class, for you to be successful in pre-calculus, for you to be successful in calculus, one of the most important algebra skills is the idea of factoring, knowing how to factor something. And in Algebra 1, you spend a good amount of time factoring, and we're going to do a lot of those same things. In this chapter, we might add one or two new things, but today's lesson, I didn't want to add anything new. I just wanted to refresh your memories on a few of the factoring techniques, but next time, we're going to learn a couple other methods that maybe you haven't seen before, but I wanted to start just with a little bit of review. Now, remember what it means to factor in general, okay? If I have the number 10, and I ask you to factor the number 10, well, we could break it down into 2 and 5, right? The whole idea of factoring is you're trying to figure out what was being multiplied together to begin with to get the thing you started with. When you have that idea of factoring in your mind, it makes factoring so much easier, and it helps you check your answers when you get them in the end. In the end, if you multiply your things together, you should get back to where you started. If you don't have the right answer. So a few of the methods that hopefully are reviewed to you are GCF. And this is the thing we always look for, is what's the greatest common factor? What can we take out of every single term? And if I look at this first example, the way I go about a GCF problem, I think, okay, what goes into 6 and 10 evenly? Like, what's the biggest number that goes into 6 and 10 evenly? And that's 2. So I'm actually going to pull a 2 out. Any GCF comes out in front of the parentheses. Then I look at the x's, okay, and I think I have to take the same amount of x's out of every single term. And you want to take as many as you possibly can. So if I have to take the same amount and I want to take the most possible, if I have 4 x's in the first one and 5 x's in the second one, well, I can take 4 out of each one. So I'm actually going to take out x to the 4th from each of these terms and pull it out in front. And then I look at the y's. I have 2 y's here, and I have 1 y here. And I want to take the same amount out of each, and I want to take the most possible. So I can take 1 out of each. 2x to the 4th y, that's my GCF. That's what I can remove from each of those terms. Well, now I'm going to figure out, okay, if I remove those from each term, what's left over? And then this is where division comes into play. Now I'm going to take each term and divide it by the GCF. So 6 divided by 2 is 3. I had 4 x's here, but I took them all out. That's what that x to the 4th is on the outside, so I don't have any more x's left in that term. I had 2 y's right here, but I'm only taking 1 out, so I'm going to have a y left over. So 3y is what's left from that first term. Whatever sign is in the middle, bring it down. And now I do the same thing with the next term. 10 divided by 2 is 5. I had 5 x's here, and I'm taking 4 out, so I have 1 left. I had a y to start with, but I'm taking the y out, so I don't have any y's left. And that's my answer. Those are my factors. And it's a very quick check. You don't have to check, but it is a very quick check. If you would distribute 2x to the 4th y inside the parentheses, you should get back to where you started. And if I do that, I would get 6x to the 4th y squared, and then 10x to the 5th y. It would work out. And that's my answer. So we always look for GCF first. Every factoring problem, we look to see is there something I could take out of every single term. And sometimes there is, and sometimes there isn't. So for instance, if I look at the next one, okay, there's a 1 in front of x squared that we just don't write. So there's nothing I can take out of 1, 6, and 16. Some people make a mistake and say, well, I can divide the numbers by 2. Well, no, you have to look at all 3 numbers, and nothing goes into 1, 6, and 16 evenly other than 1, so we don't need to worry about it. Then I look at the letters. Okay, I have x squared, I have x, and I have no x's here. I can't take any x's out because I have to take the same amount out of every single term, and there's no x's on the last one. What that means is there is no GCF on this problem. There's no GCF. But there is still a way to factor this. This is where you learned back in Algebra 1, hopefully, to find a pair of numbers that multiply to be this number and add to be this number. I need to find two numbers that if I multiply them, I get negative 16. And if I add them together, I get positive 6. Sometimes it helps students to kind of list the pairs off to the side, right? Like 16 and negative 1. That would multiply to be negative 16. But that doesn't add up to be 6. So that's not right. 8 and negative 2. If I multiply those, I get negative 16. And if I add those, I get positive 6. Those are my numbers. That's it right there. That's my pair. And the way we write our final answer, we have two sets of parentheses. X plus 8 times x minus 2. And you could go through and distribute this out to make sure that you get, what you started with. It's just a very quick way to check that you do have the right answer. That's it. Those are the factors. We're not solving anything. In Algebra 1, you learn then to solve. You would say x equals 2 and x equals negative 8. We're not solving anything in this chapter. So once you factor, you're done. We will get there, but we're not there yet. So once you factor, you're done. And then the last one we're going to do today is called a difference of squares. Difference of squares. This is when you are subtracting two perfect squares, two things that you can take the square root of. This is probably the easiest one, but for some reason it's the one students miss the most. It's really bizarre. But the way it works is this. We're going to take the square root of each term. So x and 4. Take the square root of each term. And then we're still going to have two sets of parentheses. We're going to take those two things, and we're going to add them, and then we're going to subtract them. X plus 4, x minus 4. And that's how you can always factor a difference of squares. And again, if you multiply it out, you don't have to do this, but I'll show this one. So we get x squared minus 4x plus 4x, and then minus 16. And then these middle ones would cancel, and then you get back to where you started. A common wrong answer, I'll do this in red, because a common wrong answer, maybe not, there we go. Students know to take the x and the 4, and then they just do this. They'll write x minus 4. Well, your final answer has to be equivalent to what you started with. X minus 4 is not the same as x squared minus 16, so that 100% can't be the right answer. I'll do just a couple more quick examples to make sure we got the hang of it. So let's do x squared minus 6. Okay, well, I don't know what's going on there. Minus 6x plus 8. I always look for GCF. There isn't. I can't take anything out of all three of these terms. But this is the whole quadratic trinomial. We have x squared, and there's three terms. So this is where we're going to find two numbers that multiply to c and add to b. When I say multiply to c and add to b, quadratics are generally written like this, ax squared plus bx plus c. So when I say what multiplies to c and adds to b, that's what I'm talking about. What multiplies to the constant and adds to the middle number. And so I need negative 4 and negative 2. If I multiply those, I get positive 8, and if I add those, I get negative 6. So I would write x minus 4, x minus 2. And then the last one, if I wanted to factor this, again, always look for GCF, but nothing goes into 9 and 16 evenly. This has two x's, but this one over here has none, so I can't take any x's out. There's no GCF with the x's, and there's no GCF with the y's. There is no GCF. But this is a difference of squares. It's important to know how to factor, but you also have to know when to do each factoring technique, which we'll talk about next time in more detail. But this is a difference of squares. So I'm going to take the square root of each one of these terms, 3x and 4y. I always write them out. You don't have to, but I like to write them out. And then I'm going to add those and subtract them. So 3x plus 4y and 3x minus 4y. All right, and you'll get a little practice here, a few problems to practice this. And like I said, next time we'll talk about a couple other factoring techniques.